Hi, this is Dan Bollier at Real Time with IPC. Today I'm talking with John Coonrod, who is the Market Development Engineer with Rogers Corporation. John, thanks for being with us today.
My pleasure.
Really appreciate it. So tell us a little bit about your job. What do you do over there at Rogers?
Certainly. I've been with Rogers a number of years, a little more than 20 years actually. And right now what I've been doing as a Market Development Engineer is I'm really a technical resource for the marketing department. And what I do mostly is electrical characterization of our high frequency laminates. And I may get some circuits made and have it on a variety of our different materials. And then I'll simulate some of the applications where our materials are used to understand the performance of our materials in a particular environment.
So this is mostly in the thermal. You're looking for thermal characteristics, that kind of thing?
Some of it is thermal, and I am presenting a paper at the show this tomorrow, as a matter of fact, that's related to thermal management. A lot of the things I do are really electrical and not thermal related, so it's a little bit of both, and they are interrelated. So high frequency applications, you do have thermal issues related to the performance of the circuit at high frequency applications.
Okay, and that's become much a bigger thing. I remember years ago working on coefficient of thermal management materials, and I was working with one of the few companies that did it. Now it's a very common technology, isn't it?
Right. Yeah, actually as technology is advancing, thermal management becomes more and more critical. And there's several different ways to look at thermal management. From a property standpoint, we typically think of the CTE, coefficient of thermal expansion, the glass transition, things like that. But there's also some other issues with the laminate itself that are property related, such as the thermal conductivity. And the substrate, for instance, that we have, the 6035 HTC, that particular laminate is formulated to have very low losses for high frequency, and as well as very high in thermal conductivity, and that helps move the heat through the circuit.
Okay, so I know you're involved with the marketing end of this. How do you choose projects? How do you do your research to say, hey, let's get involved in this and not in that? Because I'm sure every sales guy in your company has a different idea of what to go after. So how's that selection done?
Yeah, I'm actually pulled several different directions because we are, our materials are used in such a diverse way throughout the industry. But typically, I think we choose our projects based on where the industry is leading. So we know that thermal management's been a big deal over the years, and it's becoming more and more critical as technology advances. And that's one issue. Another issue is materials that we've been developing lately are in regards to high-speed digital and also thermal management of high-speed digital, as well as halogen-free. So halogen-free seems to be getting more and more attention. So now trying to get a material that's good for thermal robustness, halogen-free, it's multi-layer capable, and these different things that the customers are asking for. It's actually not easy to formulate a laminate like that, and that's one of our latest endeavors with a new product that we call Theta.
Okay, tell me a little bit about that.
Yeah, Theta is actually a newly developed
What is
product.
the word again? Say that again.
Theta. It's
Theta,
like the it's like the symbol theta.
Yeah.
And anyway, that particular product is intended to be used well, a variety of ways, but one is for high layer count multi-layers, and some of the more complicated high layer count multi-layers may have multiple laminations, sequential laminations. So you may have buried vias and things like that, and there's a lot of materials out there that may be all multi-layer capable, but they may not be able to do that sequential lamination. It's really a major thermal stress on the inner layers. And then by the time you get the multi-layer built, then you go through assembly and soldering, and that can even stress it more. So the idea with Theta was to get a halogen-free flame retardant system that is also multi-layer capable, as well as sequential lamination, also capable of lead-free soldering, and to have good electrical properties for the high-speed digital market.
Okay, so it's not just the end product characteristics, you're actually dealing in manufacturability as well.
That's true, yeah. And we're trying to please the circuit fabricator as best we can, but also have the right properties for the end user OEM, and of course there's assembly issues in there as well. But that's really the intent, is formulate something that's friendly for the circuit fabrication but has very good end use properties.
Okay. One of the things that I'm really interested in, because I'm more in the marketing end of this, and I really care about the American industry as well. When you're developing these products, are you getting characteristics or the basis for the product with board shops here around you? I know you're in Chandler, for example, but You know, how do you work that?
Yeah, we actually have a worldwide team of tech support engineers. So we have engineers that are at the fabricator sites. We also have application people that are at the OEM sites.
Okay, yeah.
So we have a lot of input coming in from the field of circuits that are being made with our materials at the fabricator.
Okay.
So a lot of our technical support engineers, the TSEs we call them,
yes,
they bring in a lot of information about fabrication related issues for issues with maybe drill life, speed and feeds for drilling, lamination cycles, too high a temperature, too much pressure, different things like that.
Okay.
So we try to take into account all that when we're trying to formulate a material and make sure the material is friendly to the fabricator. And at the same time, we talk with our applications people that's at the OEMs that understand the end use needs and try to incorporate the end use needs along with that.
Okay. How do you see, a couple more questions, how do you see our industry going in terms of technology, a year from now, 2 years from now, 3 years from now? What's your opinion?
I think some of that is really based on the papers I wrote. I think thermal management is one of the papers I wrote, and I think that's really where the technology is going. As you try to do more and higher speeds, you're generally going to generate more heat, and you have to be able to deal with the thermal management, and that's one of the papers I'm talking about. And then the other paper that I'm going to be presenting is in regards to Theta, the newer material that we developed. It's for high-speed digital, but it's also a halogen-free material. Okay. And some of the high-speed digital applications or designs are getting more and more complex, and as they get more complex, they have to run into these stacked microvias and sequential lamination, which a lot of materials can or can't do, and the few that can do that are usually not halogen-free. So I think some of the things I see coming up in the future are really based on, that's some of the reason why I put together the papers that I'm presenting.
And these papers, what are the times again? You're giving them tomorrow?
Yes, tomorrow, Thursday, March 1st, 9:30 is the first one, and the second one, the first one, 9:30 is the thermal management paper. Second one at 11 o'clock, I believe, is the paper for Theta.
Okay. Well, I really commend you and Rogers, because I really like the idea that you work with the board shops. That's what my business is helping the board shops. Right. A lot of them are poor, a lot of them don't have a lot of oxygen, and the fact that you can help them when they're engineering, I think is a big deal and to be commended.
Right. Well, thank you.
So I appreciate it. Yep, well, one last thing, what do you think of the show so far? I know you've probably been cloistered somewhere, but...
Yeah, I haven't seen the show a lot, but from what I've seen so far, I like it. It's obviously, there's a lot more exhibitors this year than last year, so that's a plus. Right. Seems like it's pretty well attended. I know at our booth we have a little bit of influx, where I think some of it has to do with people coming and going to papers, but we've had several visitors and it seems to be pretty good traffic. So overall, it looks very promising to me.
John, thanks for being with me today.
Thank you very much.
We've been speaking with John Coonrod from Rogers Corporation for Real Time at IPC. This is Dan Bollier. Thanks for watching.